Hi, so we're again talking about our formal models used by economists to model greenhouse gas emissions. And in the previous models, we talked about individual products. So we talked about electricity or aluminium or transport. What we want to do today is aggregate across all activities that pollute. So we want to add up the pollution by the fossil fuel-based electricity, the travel, the ruminant animals, and so on. So this model has, on the horizontal axis, the aggregate level of greenhouse gas pollution. So this is the number of tonnes of pollution per year, or we might also put it on the magnitude of climate change. Whereas before we had the quantity or number of kilowatt hours of electricity or 100 kilometres we travelled. And on the vertical axis, we're now going to have the price of pollution. In the previous commodity model, we had the price or cost of producing the desired product. So if we think about this diagram, on this horizontal axis, we've got the quantity of greenhouse gas pollution. So here we've got very little, and as we move further out here, we have more and more greenhouse gas pollution. And if in a country somewhere like Australia, this is about, current is about 600 million tonnes per year of carbon dioxide equivalent. And on the vertical axis, we start at zero, with the price getting more and more expensive per tonne of, say, greenhouse gas emissions. So in building this alternative model, we want to have two curves, a supply cost of pollution and, if you like, a demand or benefits of pollution. And so for the supply cost, we have our old friend, the MEC, or marginal external cost curve. And so that says as there's more and more pollution, then there's more and more climate change, and that climate change has more and more severe or additional effects on agriculture, sea levels, our buildings, and all that sort of thing. What's new is we're going to add a marginal abatement cost curve, or a MAC as I call it. And it shows the additional or marginal cost of reducing pollution. And so if we think about reducing pollution, how do we do that? Well, think about electricity. We can use more expensive but less polluting ways of producing the electricity. So we could close down our coal-fired power stations and then initially move to gas. And then we could close down our gas-fired power stations and use wind or solar or even nuclear. And under current technology, these are more expensive ways of producing electricity. Or I could substitute products in our consumption which provide the same sort of well-being, but they're more costly. So if I wanted to get from home to the university, I currently choose a car because that saves on time, and I get there, I can sleep in, hop in the car and get to the lecture, and that's okay. But that involves pollution. So to reduce pollution, I could actually wake up a bit earlier, and that would be a bit adverse because I'd have to get over the hangover a bit easier and quicker, and I'd have to spend some energy walking to the university. So I would regard that as buying a package of products that are more expensive. Or I could, for example, trade in my washing machine or dishwasher for a more energy efficient but more expensive option. Now in the market solution, we treat pollution as a free good. That's been the old story. So the price of pollution is P0, and at that level of pollution, we have a level of pollution which I'll call quantity business as usual. So the story is going to be that as I reduce pollution from my current market system, quantity business as usual, I'm going to have to choose more expensive and less polluting ways of production, that is, replacing coal-fired with gas or renewables. And I'm going to have to choose poorer substitutes. I'm going to have to walk to university instead of driving a car. And so price is going to rise with quantity. So here I can represent my diagram as before. So again, I have on the horizontal axis quantity of greenhouse gas pollution, and on the vertical axis I have the price or cost per unit of pollution. Now in the current world where I regard pollution as free, then the price of pollution is actually equal to zero, and I operate at this point where the marginal abatement cost, the MAC, also is equal to zero. That is, I don't take any account of the pollution and how it affects climate change. So that's the original solution. Now, if I bring in and recognise that pollution costs me, that is, I have the marginal external cost curve for pollution, and I want it equated with the marginal abatement cost of pollution, then I'm going to choose an equilibrium point here, E, where the marginal abatement cost of pollution, of reducing pollution, is just equal to the marginal external cost. So I'm going to shift pollution from quantity business as usual to quantity Q star, and that means that pollution has now an official price, P, per unit of pollution. And for society, that's going to be the most efficient level of pollution. Now we can also use this diagram to work out why I would reduce pollution. Suppose I started out here. This is the market solution, where price, pollution is equal to zero. And I ignore the external costs. Now if I reduce pollution by a little bit, then yes, I'm going to have to incur some additional costs. This is the MAC. But I've also saved this amount of marginal external cost. So I'm actually ahead by this amount. That's the gain by reducing pollution from business as usual. That's why I would want to do it. And if I kept going, I would get gains all the way to this Q star. So this whole area, A, is a net gain to society of reducing pollution. So this is another way of saying it's in the interest of the globe to reduce pollution. And further, we can reduce it to the point where the marginal abatement cost curve just intersects the marginal external cost at Q star. But unfortunately, this is not a free feed. We can also work out that there are people who lose, because remember, the marginal abatement cost says as we reduce the amount of pollution, as I move this way, I'm making people make more costly choices. I'm having to produce my electricity by more expensive ways, but less polluting ways. I'm having to wear more clothing to keep warm rather than use electricity-generated air conditioning. I'm having to walk to work more often, or choosing to carpool with my neighbour who I really don't like listening to. So these are the costs. So we actually have some losers, and these are the area B. And so while there's a net gain to society of reducing pollution from quantity business as usual to Q star, there also are some losers and some costs. And that, of course, is the real political challenge. So pulling this story together, what are some observations on the socially efficient level of pollution, Q star, relative to the old market system? Well, first, you don't reduce pollution to zero. Normally, some pollution is worthwhile. Second, we can tell that the optimal pollution is not just a technical level. For example, the Kyoto Agreement said we ought to get back to 2000 level pollution. Or some scientists have argued we should get to, say, 500 parts per million, or we shouldn't let the temperature get more than 2 degrees centigrade higher. Well, it also depends on the costs and benefits. And there's no guarantee that that marginal abatement cost curve and that marginal external cost curve will intersect at those technical levels. We have to have information on the costs. So the optimal level of pollution and the quantity of different products we produce and consume and the way we produce them requires data on emissions and their effects on climate change. So that's all that important technical stuff that you've covered in this course. But it also depends on the costs and benefits of pollution. And we represented those by the marginal external cost curve and the marginal abatement cost curve. And surprise, surprise, they're very hard to estimate. There's much uncertainty about the actual position of those curves. And a further observation is that those marginal abatement cost curves and marginal external cost curves will shift over time. So the optimal level Q star and the optimal price, where the MEC is equal to the MAC, is going to vary over time. So if we're really serious, there's not going to be a once-only solution to what's the right amount of pollution. It's going to change as we get new information about those curves.